The Gawler Craton Airborne Survey has been in progress for nearly 2 years now and is over 90% complete. But today I'd like to start at the beginning and talk about why we did the work. And really what it comes down to was that the PACE Copper program, which was the initiative behind it, and the copper strategy drove the idea to embark on this program. The copper strategy has an aim of tripling copper production by 2030, and we believe that the Gawler Craton is going to be the place that those discoveries will be made. Okay, so that's backed up by history, which tells us that as the resolution of surveys improves, discoveries are made on the back of that, and regional surveys that have been done over those decades by government have also resulted in numerous new discoveries being made, and we believe that this survey will be no exception. So we undertook a survey of 200 metre line spacing, 60 metre ground clearance, over 1.6 million line kilometres, over a huge area, and a large number of landowners and land parcels involved at a cost of about $10 million. And we made a commitment at that time to really try and raise the standards of how these surveys are done, processed and delivered. And the rationale behind that is maximising public value. Our aim was, and we believe we've achieved that aim, to use best practice across all areas, from how we're engaging with the communities through to how we're dealing with the data, to how we add value to that data and deliver it. So these key outcomes became our guiding principles for the survey, and it begins with communicating with the community and landholders, and started with landholder notifications, and we were meticulous about how we sent those notifications out, the type of information that we provided along with those notifications to really provide all the information that landholders needed when we start flying a very large survey. All of that information leads back to the community information webpage, which we set up specifically for the survey. And that page has an integrated GIS map, which tells landholders on a weekly basis where the planes are going to be flying. It enables them to easily download data with a few mouse clicks. Both the field data releases data packages, as well as value-added enhanced data that's released subsequently. There's frequently asked questions on the web page. The survey contractors can be contacted directly through this as well, and this has really been great because landholders have been able to talk directly to the contractors if they've had any issues or any questions. There's a subscription service, so people can just pop in their email and receive updates whenever a section starts, completes, whenever new data is released. So if you want to keep up with the progress of the survey, there's no better way to do it than through the subscription service. And at the moment, I think we've released 24 updates to those subscribers. So a few stats there. So we think it's working really well. We're getting a lot of page views. We can see that there's a lot of views to the contacts page, which tells us that people are engaging with the website, but the most satisfying statistic on there is the number of complaints we've received. For a big survey of this size, having 0 complaints, I think, is a real testament to the quality of what we've done there. So part of this process was working with Geoscience Australia, and we did a complete update of the specifications for the survey for airborne magnetic, radiometric and elevation data. And the aim of that was really to be able to capture in digital form every instrument that's on that aircraft that's measuring data. We wanted to get the best quality digital data from every instrument on that platform at the highest resolution and precision possible. and that did mean going right through the specifications and making sure they were up to date. So another part of the survey that's really beneficial, and its real benefits will come out when the survey is complete, is the Whyalla Test Lines. So every aircraft that flew, and there were 11 aircraft from 4 contractors that flew the survey, but before they actually started the survey proper, they flew these lines that were 20 kilometres over water, 75 kilometres long, the same specifications as the rest of the survey, 60 metre ground clearance and 200 metre line separation. And the aim of these Whyalla test lines was a direct comparison of the systems, specifically the radiometric systems, which can be very complicated when comparing, and can be very complex to actually merge those data sets afterwards due to a range of effects from calibration to environmental effects. So all of the aircraft were calibrated in Western Australia as part of the requirements to fly a survey, but they then flew these Whyalla test lines. And the information on the screen now shows some of the radio element means from those test lines. And in an ideal scenario, if the calibrations were all done perfectly, the values that you'd see on those radio element means would be very close to similar, probably within 10% of each other. But we actually see that that's not the case. The highlighted numbers there are the minimum and maximum of each of those radio element means for potassium, thorium and uranium. And we can see that there's some departure. The fact that we've flown these test lines and that we've measured and have captured all the sensitivities of the instruments means that we can actually use this information to do a much better job of the survey levelling at the end of the project. The other thing that's good about it is the contractors themselves can actually compare their instruments with their peers, and if there are any issues that they find, they can then take the steps to perform recalibrations or better understand why there are differences in the calibrations in the first place. So we're really providing a service not just to our customers and ourselves, but really to the whole industry. So this just outlines some of the ways that the levelling processing would work ultimately for the radiometric data. I won't dwell on them too much, but it basically is around selecting one of those sets of sensitivities, fitting the other data to that, and then working through the process of shifting the data to fit the selected data set. So that's all been put together in a report which will be released at the conclusion of the survey. And moving on to QC details. So the QC process involves the GSSA working with Geoscience Australia, but also working with the contractors. And we found that the best way to facilitate that whole process was to use these online Google Sheets, which is a free service. It's basically a multi-user spreadsheet, and we were able to basically capture a complete audit trail of quality control, right from the raw field data through to final raw edited data, to preliminary gridded data, and right through to final deliverables. So there's no confusion about who said what, whether something's been addressed or not. It's all captured in the Google Sheets, and this has just become what we think is the way forward for us anyway. So looking at a few results now. This is a radiometric image comparing the best available data prior to the survey and following the survey. And I think I don't really need to sell anything here. The results are obvious. We're seeing just unprecedented clarity in the radiometric data. And the radiometrics, I have to say, is probably the most challenging part of quality control for the contractors processing and us. And we're getting fantastic results with that. Here's another image of around the Peak and Denison ranges. We're just getting incredible information about landform processes and movement of the elements across the landscape. Moving on to some of the magnetics. Often when you look at a magnetic image, sort of at the large scale, it's hard to see differences between the old data and the new data. It's not until you start to really zoom in and look at things in detail, or you start filtering that data, that you really see the differences between the old and the new. And so I've highlighted a couple of areas that show the old data where we've got survey boundary artefacts, where we've got just a lack of detail at the surface, at the near surface information, and also a whole bunch of levelling busts, none of which you'll find in the new data. We've really been very meticulous about making sure that the filtered data that comes out of this survey is fit for purpose and ready for use. Here's another area where we actually thought that the existing data was really great, but when you put it next to the 200 metre line space data, you just see an incredible amount of geological detail coming out of it. So we didn't want to leave it there. We wanted to add even further value to the data, so we partnered with Clive Foss from CSIRO, and each of the data sets that come out of the GCAS survey will have about 12 filtered images with a bunch of transformations that basically enable explorers to hit the ground running with their geological interpretation of that data and analysis. We're also providing a number of vector products like contours, gradient strings, as well as magnetic 3D depth models. And those depth models are really something else, which I'll talk about in a moment. An example of some of the data enhancements, this image on screen now is it's a pseudo-gravity draped over a tilt image. And what you can see with that is you can see basically crustal scale structures as well as the nearer surface information and structures, which really just make geological interpretation that much more possible, and we can get that much more information out of it. This is a second vertical derivative over the Stuart Shelf region, and just to show that the data is holding up to some filtering that really tests the data. And I'm not sure if you can see, but what looks like a few lines through that data set are actually power lines and cultural features. So we're seeing no busts even at the second vertical derivative, which is great news for everyone. We're combining the new data with our latest gravity data, and we're finding that the correlations between the magnetics and the gravity are massive, and so it's the power of each of those two data sets is multiplied when you start putting them together, and so we've done exactly that. Now those magnetic modelling I was telling you about, this is a handful of the thousands of individually modelled magnetic anomalies that Clive Foss has fastidiously modelled to get a depth to the magnetic source. All of the models are available on the data releases that we make, but what will come out of that is our ability to map the depth to magnetic source. And we can combine that with our drill hole information to even ensure that we're seeing correlation between where we know magnetic source is with the drilling and where the magnetic sources have been modelled. And the way Clive's doing this is a method that is explained in the report book that we release with each of the data releases. And so that gives you a really great technical overview of all of the data enhancements, as well as detailed information about the depth modelling. So, as I said earlier, we're over 90% through the acquisition. We've released more than half of the acquired data so far as an initial release. We've released one of the enhanced data packages, and you can see that over the next few months, we're expecting to just basically flood the market with new releases of acquired data as well as the model data. We'll be releasing the Eastern Gawler province, that's areas 3A and 3B, over the next couple of weeks. You'll get the depth modelling and all the enhanced data, and following that will be a regular series of updates. So what comes after that? By this time next year, it will all be done. But then we'll get to work on merging the data sets to reissue as a complete merged set of data. And as you can see from some early tests, these grids are merging and coming together beautifully, both the magnetics and the radiometrics. So before I leave, I'd like to acknowledge all of the people that have worked on this project, from Geoscience Australia as well as GSSA, our suppliers, the 4 contractors that have done the hard yards and flown the survey, given us the data, but also our expert contractors and Clive Foss from CSIRO. So thank you very much for listening.